Okay, so now that we know how to convert between exponential and radical forms, we're going to add simplifying rational exponents so that we can really complete this. Okay, before we do that, I want to go over some exponent rules that you'll need today. So a reminder, if you have two things with the same base and you're multiplying, two things, same base, and we're multiplying, really x to the third here really means x times x times x. And x to the fourth really means that. And if I'm multiplying all those, you'll notice now I have 1, 2, 3, 4, 5, 6, 7 of those. So this is x to the seventh. Well, a shortcut to go from here to here would be to just add exponents. So x to the seventh. 3 plus 4, that's how I get 7. So you can do that. We don't want to write it out every single time, so that's a shortcut. Does not mean we're adding. It's still multiplying. Notice there's no adding right here. It's just a shortcut to add these exponents. That's all. So by the same token, if you're dividing, the shortcut is to subtract, as you might guess. But the reason for that is, take a look at the top. X to the fifth is 5 x's. On x squared is a couple of them. And then these cancel out to 1. So what am I left with? I'm left with x to the third. Now notice, shortcut would be to just subtract these two exponents, 5 minus 2, and I could get 3. So that's where that comes from and why it works. Power of a power property. If you have an exponent outside of another exponent, you really, this is, remember, the same as x to the third times x to the third, which would be x to the sixth. The shortcut would be to say just multiply these two. That's called the power of the power property, and that's how we get x to the sixth. Okay, a couple of other ones. So this is still the power of power property, except a lot of people forget that this 5 is still being taken to the third power as well. So if you see multiple things in here, don't forget all this power of 3 goes on all of those. So this would really be this here, which would give me 125 x to the 12th. Okay. All right. So negative exponents, really to get rid of that negative exponent, you have to move it, and you have to use this same property. And what I mean by move this is this really moves to the bottom, and then it becomes a positive exponent. And we need a placeholder up top, so we put a 1 for that. Okay, and the reason for that is, let's say I were to take these two and switch them. Okay, x times x. Now I have this. So these would cancel now. Okay, if I subtracted those, just like we learned before, you know that here this would be x to the negative third power, right? Well, what am I left with? I don't have anything on the top, so x divided by x is 1. And on the bottom, I have x to the third. Notice these are the same. And that's why the shortcut is to just take this x to the negative third, move it to the bottom, put a placeholder on the top, and now it becomes positive. Okay. This one here, got a negative exponent. I'm going to put it on the top and the bottom. And now you're going to move that. So this is going to get moved to the bottom, but if it's our negative exponent, it's already on the bottom, gets moved to the top. So this really just ends up becoming 3 squared over 2 squared, which would be 9/4. So some just review of some exponent rules. They'll be helpful. Maybe review those couple of things if you ever get stuck. Okay, so now how does this work? Simplifying expressions with rational exponents. The first thing you want to do is rewrite all radicals in exponential form. Now the first couple of slides, you're not going to see any radicals yet. So a lot of times this might not be a necessary step, but if you see radicals, put them in exponential form first. Then you're going to use the rules that we just talked about, exponent rules, and then make sure your answer is simplified and simplify anything that you need to. There's a couple different ways you can do that, and I'll talk about that here in a second. All right, so this is same base. What do we do, right? If they're the same base, we're multiplying, we can add the exponents. So I'm gonna add these exponents. Now in order to do that, the denominator has to be the same. Remember, when you're adding fraction, denominator has to be the same. Well, they are, so we're good. However, this is not completely simplified. So you really have two options to solve this. So the first one would be to convert this right away into a radical, and then simplify like we've been doing. So let's see. Okay, I have 3 x's can go here, and that would give me 2 left over. So this would be x. Okay, that's one option. Another that people like to do is use the fractions and break apart this fraction before you convert. So into thirds. So the biggest one that I could do is 3/3, and then I have 2 left over. Okay, well, this is just x to the first power, and now I can convert this one. So this would be that, and now I'm simplified here. Either way, you notice you get the same thing. So do whichever one feels most comfortable for you. Those are a couple different options for you. Okay, here's another one. Notice I have same base, so same base here, so I'm good, but the denominators are different, so I need to change denominator. This is going to have to become a 4 on the bottom, so I have to multiply the top and the bottom by 2, so I get 6/4. And then now I can add these, so I would have 7/4. Okay, so now I'm going to split this apart. Okay, and I guess I'm going to do it this way. 4/4, 3/4. So this would be P. There we go. So now if you did the other method, you still should get here. Okay. Hopefully those make sense. Okay, so again, a couple other things. Rewrite all radicals in exponential form. You'll notice none of these here have radicals again, so that won't apply. That will be on the next one. All right, so here, same thing. I can subtract because I have the same base, but when you're subtracting, you need common denominator. I don't have that. So I got to make that top one a 4 in the denominator, so that means doubling the top and the bottom. Okay, so this is going to give me, subtract now, that would give us 3/4. And now this one I can't break apart, so I'm just going to convert right away. 3. There we go. And you're done. I'm going to kind of work my way this way, I think. Okay, so here's a power of a power. Now when you do that, power of a power, you multiply these. And when you're multiplying fractions, you don't need a common denominator, right? So this is just going to be a to the 5/6. Maybe erase this so you can see a little bit better. 5/6 power. And then now I want to rewrite that. Go back to radical form. Make sure your answer is always in simplest radical form. So 6 out here. And there we go. That would be my answer there. Okay. Power of a power. So this would be 32. 1/2 times 1/2. So multiplying these would be 1/4. Okay. So this is going to end up then being 32 to the first power, taking the 4th root of that. And then can I simplify that? Yeah. Let's see. The 4th root of 16 and the 4th root of 2. 4th root, not square root, so be careful. That's 2. Okay, so that would be my answer there. All right, let's try one that's got a little more going on here. So this one, be careful. Remember the 2/3 also needs to apply here. So this is 8 to the 2/3 power, and then x, now I'm going to multiply the 2/3 times 2, that'll give me 4/3. Okay, now what? Well, the denominators are both 3. So when you rewrite this in radical form, that's going to be an index of 3. And then I'll have 8 squared x to the 4th. Okay, now I'm going to simplify this. This would be the cube root of 64 x to the 4th. And I can simplify this even further. So this would be cube root of 64. 64 is a perfect cube. X to the 3rd could go here, and I'd have 1x left over. So I guess the cube root of 64 is 4. This would be x. So I'd have that. 4x times the cube root of x. Okay. Hopefully that makes sense. Okay. So once again, it says rewrite all radicals in exponential form. That was kind of a key thing. We're going to see that here come up on the next thing. It didn't apply here. So now you'll see that on some weird ones. Okay. And a couple ones with radicals now. Okay, this first one doesn't have a radical, but has a negative exponent. So again, you see this. To get that to be a positive exponent, we want to move it to the bottom of a fraction. And then I have a placeholder that's going to be a 1 on top. Okay, so this means the square root, I don't need that. And it's 100 to the 1st power, so that'd still just be 100. So this would just be 1/10. Cool. All right. Finally, now we have some with radicals. So step 1 always is if you see a radical, change it to exponential form first, and then you can do some of your multiplying. So this would be v to the 1/3 times v to the 1/2. Now our multiplying, which says we add exponents, right? So that these are not common denominators, so I'd have to fix that. So this would be 2/6 and 3/6. So this would be 5/6. And then I'd want to rewrite that. Let's see, that would be back in radical form. 6 v to the 5th. And I can't simplify that anymore, so that would be it. I would stop there. Okay, a couple other weird ones you're going to see. Another one with negative exponents. So let's see. I know that this is going to be negative 2/16 to the positive 1/3 power, 1 up here. So this would be the cube root of negative 2/16 to the 1st power. 2/16 is a perfect cube. Well, this would be -6 because it's negative. That would be 1/6. So that one also works out pretty nicely. Okay. Let's try this one. Okay, I've got radical in the denominator, so I'm going to change that to exponential. So this would be 1. Well, it's kind of hard to see, so sorry about that. 1/3. Okay, now I have the same base, 4 and 4, but what's the exponent, right? Well, the exponent's not written here, but it's really a 1. Okay, well, in order to subtract the exponents here, I need to have a common denominator. So that's 1/1. I want to multiply. I need it to be 3. So I'd multiply the top and bottom by 3. I'd get 3/3. Now 3 divided by 3 is 1, so that works. Okay, Now if I subtract, I'd get 2/3, and then rewrite. Let's see. Okay. So this is 16 cube root of 16. I can break that apart, right? So this would be cube root of 8, cube root of 2. So this would be 2 times the cube root of 2. A little more going on. That one's kind of a weird one. Like I said, these are a bunch of weird ones. All right, one more. Then I think you've seen all different kinds that you can see. Okay, 25m squared. Again, a radical here, so I'm going to convert this 25m squared. This will be all to the 1/4 power. Okay, and then now you want to distribute the 1/4 to both of these. Okay. And then you could simplify this second one, so I have 25 to the 1/4. Times m to the half. Okay. All right, so now I have this. Okay, and I can't put these together because one's a 4th root and one's a square root. So this would be as far as I could go. Kind of a weird one again. Yeah, hopefully this kind of makes some sense. Oh, that's not our... So your assignment is simplifying rational exponents worksheet. I wrote the wrong thing in there. Don't forget to write that in your planner. Review these problems as you need, and come and see me if you need any extra help. All right, see ya.